We begin with any diatonic octave, that is, any whole phenomenon expressed as an octave whose length is divided into 7 intervals by 6 notes at the diatonic ratios 1/8, 1/4, 1/3, 1/2, 2/3, and 7/8 of its length. It is drawn to scale. Any octave can be studied as a totality, that is, as something which begins at nothing and grows to be its all. This is called a scale 0 octave. Every scale 0 octave starts with a bottom do at a frequency of 0 and proceeds to the frequency of its top do, its all. Here, we choose the top do frequency to be 192, so that all of the inner scale 1 octaves will have frequencies which are whole numbers. But this choice is arbitrary. The top do frequency could be any number. Every diatonic octave has 3 inner octaves. This is especially clear in a scale 0 octave because it has within it 3 natural doublings of frequency. In this example, Re 24 doubles to Mi 48, which doubles to So 96, which doubles to Do 192. These 3 inner octaves of a scale 0 octave are called scale 1 octaves, and are mathematical or musical octaves, because any Do will double to the Do above it, or halve to the Do below it. Only the scale 1 Dos at Mi 48 and So 96 can both double and halve within these 3 inner octaves. So they are called oscillating Dos and are shown as darker circles. The range of each oscillating Do extends from the Do below it to the Do above it and is shown as a double-headed arrow. The range of the scale 1 Do at Mi 48 is shown as a solid red arrow, and the range of the Do at So 96 as a hollow black arrow. Because these diagrams are drawn to scale according to frequency, you can see that 2/3 of the length of each range goes upwards plus 2/3, and 1/3 downwards minus 1/3. The Do 48 at Mi 48 can go up 48 units to the Do 96 at So 96, or down 24 to the Do 24 at Re 24. The ranges of the 2 oscillating Dos overlap in what is called the Mi-So area of coincidence. At each of these oscillating Dos is a force wanting to double or halve, but there is also a force at every Fa also wanting to double or halve. The force at the Las is neutral and is not shown because it does not interact with the forces at the Dos and the Fas. Each force is shown as 2 triangles, one pointing up and one pointing down, with the strength of its impetus for movement, the distance it has to go to double or halve, shown as a number within each triangle. We now zoom in to that part of the 3 inner octaves existing between Fa 32 and Fa 64, where the force at Do 48 wants either to double, going up to 48 to the Do at So 96, or halve, going down 24 to the Do at Re 24. This area, as we shall soon see, will be called the minor oscillation. Let's see what happens when the upward force at Do 48 attempts to double to Do 96. As the force at Do 48 starts to go up towards Do 96, it has an initial upward impetus of 48 units. As it travels up, it loses force. By the time it has gone up 6 units to reach Re 54, its upward impetus has dropped to 42 units. By the time it has gone up 6 more units to Mi 60, it has only 36 units of impetus left. and by the time it reaches Fa 64, it has an upward impetus of only 32 units. But there, it encounters a downward force of 32 units from the force at Fa 64, which wants to halve to 32. This exactly neutralizes the upward impetus remaining of the force from Do 48. Its upward motion is denied. When the force at Do 48 tries to go down, it wants to halve to 24, so it has a downward impetus of 24 units. As it travels down, it loses force. By the time it has gone down 3 units to T45, it has only 21 units of downward impetus left. By the time it reaches La 40, only 16 units are left. By the time it reaches So 36, it has lost another 4 units, leaving only 12 units. And when it reaches Fa 32, it has 8 units of downward impetus left, and encounters an upward force of 32 units at Fa 32, which sends it hurtling back up with an upward impetus of 24. Its downward motion is denied. The force at Fa 32 is 16 units below the oscillating Do 48, and the force at Fa 64 is 16 units above Do 48. The force which lives at these Fas is therefore called a symmetrically distanced denying force. This can be likened to fixing the ends of a vibrating string, which is then forced to oscillate between the two Fas as the vibration of Do 48 travels up and down it and is reflected at its ends. This is symbolized by the green sine wave, depicting a vibrating string with its ends at Fa 32 and Fa 64, and centered at Mi 48. It is called the minor oscillation. Exactly the same thing happens to the force at Do 96, at So 96 in scale 0. It is forced to oscillate between the Fas at Fa 64 and Fa 128, where it also encounters a force which denies its downward or upward motion. This oscillation is just twice the size of the oscillation at Mi 48, and is called the major oscillation, depicted by a blue sine wave centered at So 96. Because every scale 0 octave experiences these oscillations centered at its Mi and its So, we can show this duality of the major and minor oscillations and the ranges of the oscillating Dos directly on the notes of the original scale 0 octave, without explicitly showing the scale 1 inner octaves. Exactly half of the scale 0 octave is within its oscillations. The major oscillation is 64 units in length. The minor is 32 units, for a total of 96 units, just 1/2 of the total octave of 192 units. Then, because any diatonic octave at any scale can be expressed as a scale 0 octave of the same length, this diagram will apply to any octave at any scale with any set of frequencies. The duality of the major and minor oscillations is a feature of every octave. Each Mi and So of every octave is a point of existence, oscillating within a web of harmonic stability, which occupies half of the length of the octave. And the major and minor oscillations are bound together in this structure by their overlapping ranges, the Mi-So area of coincidence.